Hey guys, today we'll be looking at chain rule derivative examples. For these examples, I'll be focusing on doing the chain rule multiple times. I'll make a few other videos for chain rule with the product rule and quotient rule, and chain rule with the power rule. So right here is our basic chain rule, and all it means is if you have a function within a function and you take the derivative of the outside function and you keep the inside function the same, and then you take the multiply by the derivative of the inside function. Alright, so for our first example, we're going to take the derivative of our outside function, which is sine, and that'll be cosine when you take the derivative, and you keep the inside function the same, which would be cosine tangent x. Now we multiply by the derivative of the inside, so this will be where the second chain rule kicks in. So the derivative of cosine is negative sine x, and we keep the inside the same, which would be tangent of x, since it has a function within it as well. And now we take the derivative of our tangent of x, which is secant squared x. And that's the derivative for this one. We can take this negative all the way out front, and we'll have cosine, and then our cosine tangent of x times our sine with our tangent of x, and then times our secant squared x. So that's the derivative for that one, and we did the chain rule multiple times. For our second one, y equals e to the secant 5 theta. So when we take the derivative, dy dx, our first function that we take the derivative of is our e function, and we know that e, when you take the derivative, let me write a better e than that, we know that e stays the same, so we'll have e secant 5 theta times, now we take the derivative of our second function, our second inside function, which is secant of theta right here. So the derivative of secant of theta is secant tangent. So we'll have a secant 5 theta times tangent 5 theta. And now we have our innermost function, which is 5 theta, and we take the derivative of that, and it's 5. So if we clean this up, it'll look like 5e to the secant 5 theta times secant 5 theta tangent 5 theta. And for our last one, y equals ln of sine of 1 minus 2x. So our outside function here is the natural log, and the derivative of a natural log is 1 over whatever our inside function would be. So dy dx, so the derivative 1 over, now we have our inside function, sine of 1 minus 2x, times the derivative of our sine, which should be cosine, and we keep our inner function the same, and now we multiply by our innermost function derivative, 1 minus 2x, which would be negative 2, that derivative. So if we clean this up, it'll look like negative 2 times cosine of 1 minus 2x divided by sine of 1, that's not a 1 there, of 1 minus 2x. And since sine over cosine is tangent, and this is opposite, we can make that tangent on the denominator. So we'll have a tangent of 1 minus 2x. And that's our answer.